Right, and we're live with Optimize Live Lab session number 2. Welcome, everyone. Hey, Rich. um, so, yeah, thank you all for joining, or whoever has so far, and everyone that watches this later as well. Um, the principle behind what we're doing today is looking at DIY behavioral personalization. So, this is your ability to essentially store what people are doing on the website. So we'll be storing it locally on their machine, for that kind of real-time access, storing what they're doing, what they're looking at, various things that we're interested in understanding, and then making sure that we're able to target people based on that behavior. So what we're going to do, I shall start by sharing my screen. Screen 2. So this, as you may be aware, is JD Sports. They sell things I happen to be very interested in, as you can see here. And, highlighting the use case of why this kind of stuff is important and useful, I guess, just to begin with. So I've been browsing men's footwear, some trainers, we can click through a couple of bits and pieces, go forward and back. So at this point, I've already kind of expressed an interest. These are something that I'm interested in. And yet, if I go to homepage, what am I targeted with as my experience? Here are some, women's, jogging bottoms, yoga pants, workout wear. Short by category, we're looking at things like clothing, which again, I've not expressed an interest in. Footwear, which isn't quite, the type of footwear that I've expressed a preference in so far. So all of these things are not relevant to me. Accessories certainly aren't as well. And yet, if you look at what I'm being presented with for, pretty much the entire homepage, perhaps down to this point at which, some of the trainers that start to show up are at least a little bit relevant. But, certainly the fold, next block beyond that, and a few more as well. And none of these things are relevant to me. But if you had all this information to hand, you can at least start to build much more personalized, much more relevant experiences for people. And it's not too difficult either, which is what we want. Looking at the industry as well, and how people do these things, quite often I've seen people charged £40,000 or dollars just to enable personalization on their account. When in reality, what we're going to do today is build it in, give or take, 90 minutes. Hopefully a little bit less, but we'll see how we go on. As usual, I've not prepared these things too well in advance, so yeah, no promises, but we'll see how we get on. But if that little time can save you that much money, why not use it to hire a developer? It might save you more as well, but why not use it to hire a developer, and then they get to work with you for the rest of the year, which in my book, especially as a dev, is a hell of a win. And yeah, that's what we're going to do today, in short. So one of the best places we always start when it comes to these kind of things is making a few notes. So what we're going to do is open up a code editor, use a fresh tab, fresh window, somewhere a bit clean to work in. We make notes in JavaScript for no reason whatsoever. Keyboard is not having a great time. That's interesting. What we shall do is keep the old keyboard aside from a minute and use this instead. So making some comments here then. So DOI should be in caps. DOI, behavioral personalization. So what do we want to achieve as part of this project? So when someone browses around the site, just zoom in a bit as well so it's easier to read. We'll not be doing updates ever. When someone browses around the site, what do we want to be able to achieve? So we want to keep track of all pages. For a given category, we want to know, and then, this is down to everyone in terms of what you're interested in, what things you feel are relevant to you. But, if we look at a website like JD Sports, the brand people are, looking at is probably quite relevant, especially not just with, trainers, but if we look at something like hoodies, so the brand is probably relevant. The price point certainly would be. Color is probably important as well, especially if they're trying to make a look which works well for them. So we can look to store these kind of things: brand, price point, and color. The list for what we choose to capture can go from there. For now, we'll start with this. We'll look at not just storing this information, but getting it back as well, and essentially keeping a real-time track of everything someone's up to. So, to store this information, the very first thing you should always do is try and model the data. You don't run into storing stuff. You don't run into writing code. That's the wrong way of doing things. Always be clear about what you want out of the system, and then making it happen becomes a lot more straightforward. So if we look at the information that we'd like out, we'll have some kind of category browsing info, which we might want to simplify the name, but we'll leave it as category browsing for now. So what we'll probably have is the name of the category. And then within here, we've got a few things that we're interested in keeping tabs on. So what brand or brands people interact with, what prices people interact with, and what colors. Using the American spelling for now, just given it's the kind of CSS. Or let's stick with UK, why not? So, this is a very simple schema, something that we can be interested in capturing. Whether or not people browse through particular categories, you would at least then be able to work out from here. If we also keep track of all of the pages that people are browsing through. So within here, we'd be looking perhaps at a timestamp and path name for the page. That way we can kind of time and date, where people have been, what they're looking at. And yeah, some of these things as well, again, useful to keep in mind are, what sorts of calculations do you see yourself doing on this information? If it's brands, are you just looking to keep track? Do you want to find out what the most recent one was? If you know roughly what type of data you want out, understanding how to store it is quite straightforward. If not, you can just load everything up into an array and then come back to it and kind of run your own calculations when you're looking at what to pull back out, which is roughly what we'll be doing here. So doing this, as you'll come to find, is pretty straightforward. One of the most challenging things when you're writing front-end code is often working out where on earth you're going to reliably find things like brand, color, prices, or whatever meta information we're interested in. So, and also when to capture is also an important thing. Do we want to capture this as people browse product detail pages? What about if they click through product lists? What if they see a certain number of products? If these are the kinds of things we're interested in, again, there's nothing stopping us from building on this kind of information, and saying, somewhere here we could say something like PLP number of products seen, and just keeping a tally, starting at 0, but keeping a tally. So we could do stuff like this as well. Again, it's just whatever feels useful to capture. So we'll start small, and as with all things, to expand, once you've done the simple stuff, it shouldn't be too challenging. So if this is the information we're going to capture, one of the first questions probably is where we're going to store it, and local storage is our preferred choice here. For those who aren't familiar with local storage, think of it as a bigger cookie. Cookies have limits in kilobytes in terms of the amount of information you can store in there, so you want to keep it quite small. Local storage, we're talking megabytes. So when you're looking at plain text in the megabytes, certainly that's an incredible amount of information that you can hold, especially for a single user's browsing when we're only holding a few bits. We're not storing the entire page for every single page they browse. So this is what we're going to store. We know roughly how we're going to do it. So we need a few methods to begin with, save to local store. So things we want to do, so kind of methods, read from local storage, store to local storage, keeping a variable, some kind of local caching, so it's easy to do lookups whenever we feel the need to. If we start by achieving these pretty basic things, it should then be quite easy just to build objects that look and behave the way we want. So that's what we're going to do. So kind of keeping everything encapsulated where we can, stopping variables from leaking into the window without us meaning to. So we have a few things that we need to do, right? One is to read from local storage. So we can just do a So if we had a variable here, which is our kind of local cache, or probably just call it O for shorthand. So what we can do is when we read from local storage, we will update our local object and then just return that object. So it's kind of easy, it's present, it's easy to pick up on. It stops us from having to pull too much information anytime we want something. The only time you really need to read from local storage probably is the first time a page loads. Beyond then, probably not necessary. So to make this happen, a few settings as well. So we'll have a key for local storage, which will be the name under which we store things. So for now, let's call it user behavior. So what we're going to say when we read stuff from local storage is local storage get item, that item. And if it doesn't exist, so we can look up that side of things now. So if we're searching for something which doesn't exist, we get back null. So what we can do is say, make it an empty object. Parse that data. So data is JSON parse because it'll come back as a string to begin with. So we want to do that, and then we can set O to that new information and return O. So anytime we want to get something from local storage now and do that kind of initial read, this will happen and it will update O in the end and return us that information. So if we do want to chain functions or something like that, we can do that as well. When the page loads, as we said, this is what we wanted to happen as well. So there's no harm in calling that either there, or we can kind of do on when the page initializes, and then we can have some helper functions here. Again, trying to keep stuff organized where you can probably helps a little bit. So that's reading from local storage. The other one is probably making an update. Whenever we make an update, we probably want to do it to two places. One is to this object, and the other is to local storage. And there's a handy little trick I use for this. So what we can do is say on a delay, a very short one, take our object, stringify it, and save to local storage. So instead of just saving an update, if we actually call this function, maybe not call it get_o. So what we're doing is actually returning the object, and if we make immediate changes to it, those will apply to the object. So if on a short delay, we say, whatever happens to have changed to that object, we then just go and save it down. Then we have our kind of easy retrieval and reference mechanism saving all in one go. So we take O and stringify it. Save to local storage. We've got ls key, and we've got data. And that's that. Obviously, running tests is very helpful. So what we can do just to begin with is grab a couple of these bits, chuck them in here. So O is currently empty. If we read from local storage, we're expecting O to still be empty. You can see it returned an empty object. O is still empty, which is all as expected. If we were to assign something to O, it will reflect. But if we read from local storage where it still hasn't yet been saved, that's empty. O becomes empty because we've kind of done a read. If we use get O, and then make some changes, after 100 milliseconds, that should have applied. So O has saved. If we look up local storage, did not realize there are this many things in here. And this is ours. So we can see it's all saved quite easily, pretty straightforward. So all this stuff works first time around, which is obviously very helpful for us. So being able to read and save is done. So when the page runs, what do we want to happen is kind of the next question. So when the page runs, we want to, and if we look back at our notes just higher up, which is always helpful. So keep track of all the pages they browse, and we want to store them in this pages object. So let's start with that first item then. Get on. So if there is no pages, then it should be an array, I think. An array. Information that we want to add is an object where we've got the timestamp, which we can get with date.now, and we want the path, which we'll reference with location path name. And then we will just push that info into data.pages. Cool, so hopefully it should work. Only one way to tell, which is to give it a spin. So data has the information that we are after. We've got a timestamp, we've got a track of what page I've loaded here. If we look up O, that is also saved, which again is great. If we look up local storage, we can see this information start to build out, this little picture of what we've browsed. And this essentially is the crux of what we're doing here. Anything that somebody browses, we just want to keep tabs on it and extract the useful information, wherever it's found and is helpful to us. So hopping back to here then, one of the first things we wanted to do was store which pages people browse on. I think we've done that pretty effectively. Next thing is to keep track of the categories that people are browsing. And one of the things as well, actually, when we look at pages or categories being browsed, the very first time that we make this object, if it is empty, there's nothing stopping us from just creating little shells for this information. Us then having to worry about whether or not it exists becomes less of a concern if we already know it exists, even for people who've browsed nothing or, done nothing. So looking here at what we want to achieve then, as somebody browses through what we'll say is a given product detail page, we want to keep track of what brand, price, and color that product is in, all kind of grouped together by the category. To do this, one of the most effective ways I've found for now is actually to use schema.org markup. This is kind of used for Google to help it scrape sites a lot more easily. But it also means that data is therefore that much more consistent. So, if you're an agency and you're trying to make this happen for a whole bunch of clients, if they're all using the same schema.org markup, at least you know that the information is probably where you expect it to be, and you've not got to go and do the exercise of discovery for every single product, every single customer that you work with. So if we look at our schema.org markup then, so this is actually a product listings page, which we're not interested in, although you can see the schema.org markup show up there for a second. So here we go, schema.org markup. We have breadcrumb list. And then we have this one here, which is, a lot more helpful to us. So this is our product details. We can see the name. We can see probably a SKU or something like that, or product ID. Looks like the same one. We can see it up and down there. So we've got name, we have color, we have a description, which we're less interested in for now. Less interested in. We have a category name, which is very helpful to us. We have offer. Inside of offer, we keep price details. So we can see the price is £55, as we can see here. That's very helpful to us. And finally, we've got the brand as well. So we can see this is a Nike or Nike hoodie, and that's described here as well. So what we need to do is work out how to identify this script tag. So what we can do to begin with is using jQuery where possible, or you can use document query selector. You can try that as well. So if we do this, we've got a few of them. What you can do is have a peek. Whoops. So have a peek at which one matches. And in our case, for the product detail pages, it's the first one, which is excellent. So if we look up what the text content is, this is what we'll see. If we look up in a HTML or in a text, again, we'll probably find very similar things as well. If you try and run JSON.parse on what's essentially JSON markup, schema.org's flavor of it, but it's still valid JSON markup. This is what we find. So we've got a typist product, and then we've got a whole bunch of information here. So what we can do, heading back to our code for just a second. Second thing we want to do, and again, comments are helpful, is lift category specific details from PDP pages. Try to avoid clashing of names as well, as I've demonstrated here. So here's our PDP data. This is what we've got. So what we can say to filter it from all the other kinds of data. So again, just for illustration, if we take that same code and we ran it on product listing page, what we'll find is that schema.org markup, slow website, still exists, but it's just referring to very different things. Come on. I think for the sake of not being slowed down by the website, we will march ahead. I'm going to see it terminate or be forced. Yeah, key bit, when we search for it, we have typist product. So if PDP data, and then the type property isn't equal to product, well, let's say is equal to product, and we'll do everything inside of this if statement just here. So if it is, then we are on the PDP page. So the information we then want is category name. So in our PDP data, again, if we refer back to the page and say, where is our category name, we can see one just here. And then what else are we interested in? Brands, prices, colors. And again, this is just kind of a, filling in the blank sort of exercise here. So how do we find the brand? We have PDP data object dot brand dot name. And not to get caught out by dodgy capital letters as well. This is where camel casing things is probably a brighter idea than the way I've named things. So we've got our brand name, and this is probably not so useful for S's, just to avoid confusion. So category name, brand, price. Price was found in offers, so offers.price. Color is found at the top level by the looks of it. Try and collapse things when you're not using them just to be sure. But yeah, top level color. So all we want to do now is inject, that bit of information. So again, if you're doing this on a delay of some description, you can just pull the object again. You can never do this too many times, except for the small hit that it'll have on the browser's performance. If not, and that things are okay, and a browser will churn through this in less than 100 milliseconds, which it absolutely will do. Then we can just refer to this same data. So I think we have data.categories, no, category browsing. Probably worth simplifying that to something like cat at some point. But data category browsing, and then we want to make sure this exists. If not, we need to create it. So we're saying if that doesn't exist, it's an object which contains some empty things for now. So by this point in our code, we definitely know it does exist. Either it did before, or we've literally just made it. So what we can then do is say two brands, we can push the brand, two prices, we can push the price, two colors, we can push the color. This is not the only way of achieving this, and again, it depends on the kinds of information you're looking for. If you store this, if I hit refresh or if I browse 10 lots of Nike hoodies, we'll have Nike written 10 times. Sometimes that's useful information, especially if you're trying to work out what is, the most viewed category, assuming you only have one merchandising slot. You can kind of, count things down, work out what's been used the most. Sometimes it's useful just to know yes or no, have they browsed it? In which case you can say, if the brand isn't in our array of brands, then push it in there. Which would be something, if you were to do it, something like if, I think includes is the right one. You could do something like that instead and say, if it's not already there, then throw it in. But for the purposes of what we're doing here, I think it's useful to always store it, and then you kind of build up a trend and a picture of, what people are showing interest in. So if we review what we've achieved here so far, 35 minutes in, give or take, plus a bit of waffle at the start. If somebody's on a PDP page, we take note of the category, the brand, the price, the color. If we don't have an entry for the category, so if this bit didn't already exist, go and make an empty shell for it, which is what we've done here. So we'll create arrays for the brand, the prices, the color. If it does exist, it'll obviously skip over this if statement. And then two brands, we add the current brand. Two prices, we add the current price. Two colors, we add the current color. It's worth noting, and the picture that you build up as you do these kind of things. If someone's interacting with filters, for example, there's nothing stopping you from keeping track of what filters people are clicking on, even so far as to be kind of grouped by the category they're showing interest in. So if I'm here, for example, and I say, I really want hoodies by Nike, there's nothing stopping me from keeping track of that as long as you have somewhere to put it and that data stays organized. Using filters is probably actually more of a hard decision for what people are after than the passive browsing as well. You can click on something and go, I'm not really feeling that, but you wouldn't know um, just looking at the data. Whereas if someone's actually clicked on a filter, that's a very hard decision they've made. Even if they're just having a look around, it's still a very, very clear, very active, kind of indication of preference. So if you do choose to pick up on these, just keep tabs on them somewhere, organize your data well. Size is also a very interesting one. If I am, for example, browsing, where's my product detail page gone? So if I'm on this page and I click on, large or Excel, and that product's been added to basket now, understanding that that's my size is incredibly useful. Why would you show, or maybe there is an argument, but if someone's in purchase mode, don't show things to them they're not going to fit in. If you only fit in large or extra large or something like that, why bother showing things that are only in small and no other size? Especially given, limited stock items, the most popular sizes will sell first. If they're not relevant, don't bother showing them. At least show them things they can buy. So if they do show an interest, they're not disappointed. To be tested, of course, which is what we do. But the principle behind all of this and the reason for talking about it, I guess, is, if the information is there and you store it, you are at least able, you are enabled and capable of then going and doing these kind of things. So hopping back. So we have now kept tabs on all these things. So what we'll do is run this block of code. If we run it from the start, and we'll also scrap, put me down here for a minute, we'll scrap a lot of these just to make sure we've got something clean to look at. Also remove some of the garbage where we're just playing around with local storage earlier. Unexpected token P in JSON at position 1. So this technically is not valid JSON. It's valid JavaScript. It's not valid JSON, and that's probably what it's not agreeing with. In which case, wrapping them in double quotes is probably what it's after, so we can give that a go. For now, we'll leave out this surrounding function just to make sure we've got access to all of our variables. And that seems to have executed. So if we look up what's inside O, what we're expecting is acknowledging that a user's loaded this given page for one. And then for this category, so men's clothing, hoodies, acknowledging the brand, the price, the color as well. So if we then take a look, here's a product they've loaded with the timestamp of when it happened. Given we used the push method, the second page load would arrive afterwards. So they'll be in a sequenced order to begin with, which is always helpful. And then we can kind of see from peeking here, this definitely looks promising. So for category browsing, we can see we've got a record that we've at least hit the hoodies category. If we look at what that hoodie is, then we've got Nike, we've got grey, we've got £55 that it's priced at. In terms of storage, that's pretty much it. We should obviously test this further, go across several products, product types, same category, different category, that kind of thing, which we can do now as well. So, with all of this looking like it works, next thing to do is say, where's the best place for me to go and test this? So what we shall do is now we'll grab still, not the wrapped code in this anonymous function, but we'll grab everything else. And the tool I use is resource override, awesome tool. So we can add a rule where we will inject a file. If I scroll down to past these many things, this is us having injected some code into the head of the page. The head may actually not be the right place to do this because the schema.org markup I think we saw was in the body. If we just take a look, note this may be the head actually. It is. Given here we have no control over where in the head, it may still be a good idea just to hit body, in which case we at least know that it's going to run that fraction later. So a few console logs probably won't go amiss. So here we are storing current page in data.pages. That page is that one there. And then we can go here as well. Is PDP. Can drop a little else and say is not PDP. Here we can say new category. Assuming we can spell it, otherwise it's a bit of a challenge. New category, information that we've added here. So the category after adding data, we can send that through. And here, just saying that we finished as well. So when you read all these console logs, you at least know where start and finish is. For that reason, let's just do a quick one for start. Refresh the page, and what do we see? And this again is the reason for doing some of these things. You see these popping up a few times. The reason is iframes, and it's starting to mess with our work. So one small change we shall make. This is where keeping things inside an anonymous function helps. If window isn't window top, return not lighthouse. So let's just clear everything from here, try again. And because all of our logs have this at the start, we can just filter the logs by that and end up with something that's a bit more easy to read. So we'll start, we're done, page is still loading, so we can hold on for just a sec. I think we're probably there now. So storing current page in data pages, it is a PDP. We've got a new category, first time round, category after storing some information, and we're done. Now, if we load this again, what are we expecting to see? We're probably expecting to see two lots of Nike Gray 55. We're not outputting what data pages has, so we can just do that as well. We should be. It's probably just not picked up by the logs. Here we are. So we can see that's here as well. So we're expecting a second entry as well. Except that this is the info that we're adding. So in fact, we won't see the full array. What we should probably do is tweak this to data pages. So now we will see the full array. So what we're going to do is hit refresh. Storing current page in data pages. And this again is where all this mess shows up. Can do is probably just terminate the page there. Second page has shown up again. Same hoodie is a product detail page. We're not getting the new one. So it's an existing one. And if we look, we've got 2 entries for Nike Grey 55. So now, if we do this and browse around a few more of these, hopefully we'll start to build up a slightly more reliable picture of what's going on. As you can see, these things run in an absolute instant as well, which is excellent for us. So we stored another page. If we're browsing, this one is also Nike. So we can see that here, but it's not gray, it's black. So this time around, we've captured black, £95, and we've captured that here as well. So we can see similar data works. Let's try and find something which isn't made by Nike. So we've got Adidas Originals. Click into that as well. So storing data, you can see our new brand name, Adidas Originals. Color is yellow or greenish, but yellow, let's say. And it's 43. So this is working, behaving by itself. One of the best bits of this, and with all the work that we do here as well, you do not need to put this in a given testing tool. You don't need to, it's agnostic. So you could literally take this and throw it in your tag manager and start harvesting all this information, not on your servers or your machines, but at least on the user's machine, ready for them to then be targeted with a given experience. So this is a category that we stored so far. So let's just go and browse another type. We've done hoodies. This time around, let's look at t-shirts. Again, we've stored our given page. It's not a product detail page, which is correct. Category, I've got a new category this time around, as expected. This is our first t-shirts PDP capture. We can see it's Nike, we can see it's black, £18 as we can see just from the left. So this is behaving itself pretty well. Obviously QA testing and all that fun stuff, make sure we do. But as far as our ability to store information is concerned, that certainly works. So didn't need to make any functional changes here beyond the console logging. So we don't need to get rid of anything. What we can do, and what is often useful. So right now we have console logs. As you can see from the site itself, polluting the console is a pain. Just generally broadly bad practice. But we still want the ability to console log and see those things as a dev whenever you choose to. So I can't record if we did this last time actually, but what we can do is build a pretty simple console proxy. So this creates a new object just locally within our function called console with a function called log, and it does nothing, which is excellent. And then what we can say is under a certain condition, so if document cookie contains, and we use you can use debug cookies or something. You can call it whatever you want. So let's just say debug equals true for now. Then console should actually equal window.console. Console log will then equal window.console.log. So if we throw this back in now, we're not expecting any console logs to show up, and they're not, despite the page loading, it did happen instantly before, so we're pretty sure of that. What we then want to do is create a cookie. And if we hit refresh this time, we can see our console logs. So this is a very simple way of sandboxing your own logs, making sure they only show up when you want to. Instead of using debug equals true, there's also nothing stopping you from saying debug equals personalization data capture, in which case you can use the same cookie name and just switch on the bits that you're after. So, broadly speaking, all this stuff is done. The next thing is then saying, how do we get information back out of the machine? So if you keep in mind that all the information, the most accurate copy is always kept in this O object, that hasn't changed. Whenever we're making updates to data, we've got to go back and update local storage and make sure everything stays accurate. But if we're not, then we certainly don't need to. And if we're just reading, we can just loop over this object and find whatever it is that we're interested in finding. So what we can do is pull out or call out a few bits of information. So things related to this page. Obviously use smaller variable names. This is for illustration. So we've captured our category name here. So call this step 3, which is extracting information for use in personalization. What we can do is start to replay some of that information. Bits of this are manual. It doesn't mean it's too tedious, as I'll show you here. You can probably do things in give or take a couple lines of JS. But yeah, they are manual the first time you do them. So, let's say we have something that we want to use in the window, and we'll call it favorite brand. No, preferred brand for this category. By default, we don't know what that is. We don't know what their preferred brand for that category is until we look it up. So in this case, we have what we know to be the category for this page. So all we need to do is traverse our fairly simple object. So we've got o.categorybrowsing.category. So that's us navigating to our category, and then brand sits within that, or brands, was it? Brands. So this is a list of all the brands. So there's a few things we could do actually. We call this 3.1. See if they have browsed Nike. Let's say we have a particular promotion we want to run for Nike hoodies. being able to look back and say, if they had browsed it, then show it. Otherwise, show them the generic thing that everyone else has been getting. Probably is a fair use case for personalization. So if these are all of our brands, includes, and then we have Nike. One of the things just to make sure are capital letters, or if you see a mix, as in when you're storing information, there's nothing stopping you from making it lowercase as well. So what you could do, lowercase. You can do that with brand, you can do it with color as well. And suddenly we're, guaranteeing things will be presented a particular way. So if all brands includes Nike, then a user has browsed Nike. And, this is a globally available piece of information. Therefore, nothing stopping us from, using that information for any of the tools that we then go and work with, testing tools or whatever it is that you're doing. Let's say we want to capture the least amount they have browsed for hoodies or for this category. So we have a minimum bar, and we want to make sure if we're promoting products, we're not showing them things when they could be spending more. Again, a pretty solid use case for, upselling products to people, but in a fairly passive way. So the cheapest product. So when you start to use things over and over again, it's worth just pulling out. So we start off with cheapest as empty, essentially. And then what we want to do is iterate over all of the prices that we've been storing. So to iterate, we're doing this category prices. So if there is, if cheapest is unset, or the price is less than the cheapest, then we found a new cheapest. So cheapest becomes price. By the time we're done down here, we can then say, and to be fair, this doesn't need to be a var, it can be a window. So cheapest prod browsed in this category. This looks a bit awful. So for now, let's just stick with the word cheapest. But you get the idea. Just give it a name that's useful to you. Collecting all this inside a single object and then referring back to that object is probably also a good idea. But for now, we're just making things as obvious and accessible as possible. So cheapest becomes the cheapest, essentially. So that's another, solid use case. if we then wanted to say, what's the favorite color for this, for this category? We'd probably need to do two things. One is to create a tally, and then the other is to work out which one is, yeah, which one is the biggest. So, so again, to make a tally, we're iterating over, in this case, colors. So we can steal a fair bit of this. And what we're hoping for inside here is something like uh, Nike to Adidas Originals 1. Something like that is roughly what we're hoping for. So, oh no, favorite color. My apologies. So we're hoping for something like that, maybe black and gray. So in this case, we are iterating over colors, as we can see and as we have collected here. So for each of the colors, if it doesn't exist to begin with, then just make, I guess you could just set it to 1, which is probably the easiest thing to do. Else, increment it. And that's the first half of things. That's, us having made a very simple tally. What we're then going to do is work out the largest one. So we can use a or key and tally. So for each of these, if it's bigger than the largest number, update the largest and also update the color. So if so the number is probably slightly more useful names as well. So for each color in our tally, the number is this reference here. So if n is greater than largest, and this is kind of a system of what comes first will take priority. So if you have two things where people are both seeing 10, obviously only one of those will get prioritized. Hopefully not too big of an issue, and you can try and work out how to deal with those scenarios if you choose to. It depends on whatever rule you choose to write. So if that is the case, our largest color becomes the one that we're iterating over here. So if we were then to try and summarize this with a single variable that we set on the window or wherever you want to put it, we're saying window dot most favored color for this category equals largest col. So, as you can see, even performing, some decent aggregation or checks or, most, least, any of these kind of things, it's not that difficult. You can find your way. You can do some of these in, give or take, 4 or 5 lines of code, 2 of which are just closing brackets. This one, again, dead simple. Actual work was give or take 2 lines of code. We're just making it look nice and neat. So iterating on any of this information is incredibly straightforward. We are also keeping track of what pages people have been browsing. So, if somebody has left the site and they come back, there is nothing stopping us from accessing pages as well and saying, where were they? It's also useful to understand any additional metadata associated with these. So, we won't jump into that for now. But, if we're capturing things like the category, there's nothing stopping us from attaching that to the pages as well. So that if they come back as part of a new session, you can just send them to that category page, for example, and say, hey, we're just helping you pick up where you left off. And not just if they've come back, but, if they come back within the same day, for example. If we're storing timestamps against these kinds of information, then that's also a pretty straightforward exercise. So, I think without kind of doing too much and coming up with use cases just for the sake of it, and to summarize what we've achieved today, then, we have the ability here to keep track of on a user's machine, everywhere they're browsing for given products that they're browsing into. You can keep track of the category, the color, the brand, the price, anything else that you want as well. Just, that's as far as we've taken it for today. Once all this information is stored, there is then nothing stopping you from coming up with pretty straightforward queries, as we have seen in point 3 onwards, where you can do simple lookups. So, for this category, does it contain Nike? Because I have a specific Nike promotion that I'm trying to run, but only 2 people where it feels a bit relevant. So there's nothing stopping you from doing simple lookups like that, from doing comparative lookups where you're saying find the cheapest amongst these, find the lowest, find the biggest, whatever it might be. If it's the largest, you suddenly have an appetite of people spending power perhaps, or, just whatever they seem to like the look of, whether they think they can afford it or not, separate story perhaps. But yeah, it could be the cheapest, it could be the most expensive. And then we've done some kind of grouping and comparison lower down. Again, a few lines of code, right? Despite talking through every little thing, every keystroke that we're doing, every decision we're making, it's a few lines of code. Would have taken someone a few minutes to come up with something like this. And this is those comparative calculations where we're saying, if we've got a list where it could be Nike, 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 Adidas, Adidas, something else, Puma, a few more by Nike, we want to understand that a user definitely has that preference, so that when we're merchandising to them, we're taking that preference and showing them a much more relevant, much more contextual journey based on information they're clearly offering up to you. So yeah, very simply done with a few calculations, and that's that. We could go and test this. It may work, it may not. Might do it just for the sake of having a quick look. We'll take all of this. So head back to here. Would be surprised if we managed it without a single error. So far, so good, perhaps. Got a few that are bubbling up. If you are filtering, make sure you don't. Nothing between our start and finished, which is good. So maybe there aren't any errors there. So again, most favored color for this category. Let's see if you exist, and it's black. If we try to understand where, where that is, or if it's accurate, we can take our user behavior object. So this category is not hoodies. It's just part of a generic men's clothing, but you can see it's black, black, black. So that certainly makes sense. Let's see what else we had stored. Cheapest product in this category is probably £18 because that's the only one. We've got 4 entries for £18 here. Have I browsed Nike? You would assume yes, because I have here, and that's true. Again, looking back at the categories I've browsed here, because it's just the one product, they are all Nike. So the answer is yes. Capital letters from earlier, lowercase from now. Yeah, those are the few bits here. So everything working, happy days. Broadly speaking, the ability in what's been 60, 70 minutes, the ability to provide your website with real-time personalization done by yourself, which, broadly speaking, is a good thing because maintaining, adding to it is within your gift if you're building it yourself. Quite often we've heard, oh, we didn't realize you could do filters, or we didn't realize you could capture sell pages and things like that. So, if you're doing things yourself, it's within your remit and your ability to go and add whatever it is that you want. Yeah, all done within 70 minutes. So, the next time somebody's asking you if you'd like to pay 40,000 or more to go and take out some of these personalization services for the, at least make sure you understand what work they're doing. It might be a lot. Maybe they're doing some magical things for you. If they are, excellent, and it's worth the money. If not, you could probably hire a junior dev even, and it would take them, maybe not 70 minutes, but with a bit of structure. And if you show them the video as well, maybe they'll get there in a week. And, if it costs you roughly that much, then you go, great. You've got 51 weeks minus holiday, but, 51 weeks of someone to go and build you loads of CRO tests and grow your team. And that's kind of what we shoot for with a lot of what we're doing in these live lab sessions, spend money wisely, do more, try and grow teams wherever you can manage. And yeah, I think with that, let's close down Live Lab number 2 for now. Give or take an hour 15 in. Thank you to anyone who has stuck around. No idea if anyone has or not. I haven't got it open actually. But yeah, thank you to anyone who has, and catch you on the next one where, again, yeah, we'll try and do something useful. Thank you.